In the previous video, we created a linear regression model in R. Using the summary function, we were able to see the coefficients as well as some other information. The output of the coefficient section of the summary function is shown here. The independent variables are listed on the left. The estimate column gives the coefficients for the intercept and for each of the independent variables in our model. The remaining columns help us to determine if a variable should be included in the model or if its coefficient is significantly different from 0. A coefficient of 0 means that the value of the independent variable does not change our prediction for the dependent variable. If a coefficient is not significantly different from 0, then we should probably remove the variable from our model, since it's not helping to predict the dependent variable. The standard error column gives a measure of how much the coefficient is likely to vary from the estimate value. The t-value is the estimate divided by the standard error. It will be negative if the estimate is negative and positive if the estimate is positive. The larger the absolute value of the t-value, the more likely the coefficient is to be significant. So we want independent variables with a large absolute value in this column. The last column of numbers gives a measure of how plausible it is that the coefficient is actually 0, given the data we use to build the model. The less plausible it is, or the smaller the probability number in this column, the less likely it is that our coefficient estimate is actually 0. This number will be large if the absolute value of the t-value is small, and it will be small if the absolute value of the t-value is large. We want independent variables with small values in this column. This is a lot of information, but the easiest way in R to determine if a variable is significant is to look at the stars at the end of each row. The star coding scheme is explained at the bottom of the coefficients table. 3 stars is the highest level of significance and corresponds to a probability value less than 0.001, or the smallest possible probabilities. 2 stars is also very significant and corresponds to a probability between 0.001 and 0.01. 1 star is still significant and corresponds to a probability between 0.01 and 0.05. A period or dot means that the coefficient is almost significant and corresponds to a probability between 0.05 and 0.1. When we ask you to list the significant variables in a problem, we will usually not include these. Nothing at the end of a row means that the variable is not significant in the model. If we look at the stars at the end of each row in this coefficients table, we can see that age and France population are both insignificant in our model. Let's now switch to R and see if we can improve our linear regression model. In the previous video, we built a linear regression model called Model 3 that used all of our independent variables to predict the dependent variable, price. In our R console, we can see the summary output of this model. As we just learned, both age and France population are insignificant in our model. Because of this, we should consider removing these variables from our model. Let's start by just removing France population, which we intuitively don't expect to be predictive of wine price anyway. We'll create a new model called Model 4, and again we'll use the LM function to predict price, using as independent variables average growing season temperature, harvest rain, winter rain, and age. Just like before, we'll use the data set wine to build our model. Let's take a look at the summary of this new model, Model 4. we can see that the R-squared for this model is 0.8286, and our adjusted R-squared is 0.79. If we scroll back up in our R console, we can see that for Model 3, the R-squared was 0.8294, and the adjusted R-squared was 0.7845. So this model is just as strong, if not stronger, than the previous model, because our adjusted R-squared actually increased by removing France population. If we look at each of our independent variables in the new model and the stars, we can see that something a little strange happened. Before, age was not significant at all in our model, but now age has 2 stars, meaning that it's very significant in this new model. This is due to something called multicollinearity. Age and France population are what we call highly correlated. We'll learn more about correlation and multicollinearity in the next video.